So, all right, we're doing the inverse of the cubic function today and graphing cube roots. I already did example 1 really quickly. I just graphed the cubic graph, and to find the inverse of this cubic graph, I switched the x and the y values, and I ended up graphing the inverse. The inverse of a cubic graph will always be a function. So yes, it will always be a function, and that's why they're going to be easier to do than last semester when we did square roots and absolute values. Okay, we should all be trying example 2 now. Graph the inverse of this function here and find the inverse algebraically. So in order to graph the inverse of the function, let me first graph this function. And remember, I taught you how to do this last week. But the way I would graph example 2 is first I would graph an inflection point at positive 4, comma, negative 1. So let me do that. 1, 2, 3, 4, negative 1. That's the inflection point of my cubic graph. And next, if there's no stretches or shrinks, all I would do is I would graph like a 1, comma 1, 2, comma 8. But here's what I'm going to do. Because there's a negative in front of my parentheses, from the inflection point, I'm going to go to the right one, down 1. So I'm doing 1, negative 1, because there's a negative in front of my parentheses. So I'm going to do it again. From the inflection point, according to the parent graph, I should be doing to the right 2 and up 8. But because there is a negative in front of the parentheses, I'm going to do to the right 2, down 8. 1, 2, 3, 4, 5, 6, 7, 8. So it's going to be right here. The other side is going to be symmetrical. So I'm going to go left 1, up 1. And then I'm going to do left 2, 1, 2, up 8. 1, 2, 3, 4, 5, 6, 7, 8. Okay, so make sure you just go ahead and graph that cubic graph however you know how to graph it. Either make a table of values or do what I showed you last week and make some transformations, or just start guessing and checking a guess. Just make sure you review how to graph the cubic functions, which is what we did last week. So example 2, I just graphed this cubic function of negative parentheses x minus 4 cubed minus 1. So here it is. Now I need you to graph the inverse of that. So to graph the inverse of this, you're going to have to switch the x and the y values. So for example, instead of graphing this first point, what is this first point? 2, 1, 2, 3, 4, 5, 6, 7. So instead of graphing 2, 7, we're going to graph 7, comma 2. 3, 4, 5, 7, comma 2. Next, instead of graphing 3, comma 0, we're going to graph 0, comma 3. Next, my inflection point, instead of being 4, negative 1, is going to be negative 1, 4. Looks like that. And then the other side, instead of graphing 5, negative 2, I'm going to graph negative 2, 5. And finally, the last point, instead of it being 6, negative 9, I'm going to graph negative 9, 6. 1, 2, 3, 4, 5, 6. So that's how you graph the inverse of a cubic graph. So that's how you graph the inverse. Next, let me show you how to do it algebraically, and then I'll pause for questions. Okay. To do it algebraically, we're going to do what we did last semester. We're going to switch the x and the y. So instead of putting y equals, we're going to go ahead and put x equals negative parentheses y minus 4 cubed minus 1. So switch the x and the y, and now solve for y. So I'm going to do a plus 1, x plus 1 equals negative parentheses y minus 4 to the third power. Get rid of the negative in front of the parentheses. So I'm going to do negative x minus 1 equals y minus 4 cubed. And then I showed you last week, to get rid of the cube, you would just do the cube root on both sides of the equal sign. The cube root It's just like the radical, except for it has like a little baby 3 there. It's called an index root. Right. So I got the cube root of negative x minus 1 equals y minus 4 because the cube root will cancel that cubic. So final answer, the inverse, so y equals cube root of negative x minus 4, and no, sorry, negative x minus 1, and then I'm going to do the plus 4. So that should be the final answer. This inverse will always be a function, so I guess instead of y equals, you can call it f inverse if you want it. Either one is okay. You can call it the little f to the negative 1. That's called f inverse. But that's how you find the inverse algebraically. So let me pause for questions. So next, let's move on to example number 3. Like I said, we did this last semester. Here it goes again. If you want to prove that two functions are inverses of each other, you're supposed to prove it by doing the f of g of x and the g of f of x. So here's how you would prove this. And you have to show your work. I think I've put this on your test and quiz, and the answer is just yes, they're inverses, or no, they're not inverses. But here's how you show your work. To check that, example 3, to check that these are inverses, first we're going to do f of g of x. So here's what I need you to do. I need you to take this entire g function and plug it in for x in the f function. So let's do that. Let's take this entire g function and go ahead and plug it in for x on the f function. So in other words, f of x is going to be 2 parentheses x minus 6 cubed. But instead of putting x here, I need you to replace this x with the entire g function. So 1/2 cube root of x minus 5 plus 6. And then let me not forget the plus 5 at the end. Okay, so now I've taken the whole g function, I've plugged it in for x, and the f function. Now simplify this mess and see if it equals x. So if it does equal to x, then we're going to do the other half. Okay, so let's try to simplify this. This is going to be 2 parentheses 1/2 cube root of x minus 5. The positive 6 and the minus 6 should cancel each other out. So that leaves me with just the cube plus 5. Okay, now that's just the 2. Okay, to get rid of the parentheses here, we're going to have to cube the stuff in the parentheses. So 1/2 cubed becomes 1/8, since 1/2 times 1/2 times 1/2 is 1/8. Next, the cube root of x minus 5, if you cube that, that's just going to become regular x minus 5 because the cube root cancels that cubic. And then finally, I have a plus 5. Okay, so let's see if this is going to give you x. And I don't think it will because 2 times that 8, that's, I don't know what that is, but that's not right. This is going to be 1/4. Yeah, 1/4 x minus 5 plus 5. This doesn't look good because then if I distribute my 1/4 here, I'm going to have like 1/4 x minus 5/4 plus, okay, definitely not x. So since this does not equal to x, then you can just put not inverses. And honestly, if the first one, like if the f of g of x is not an inverse, then you don't even need to do the other one. So on the quiz, to save you time, if the first f of g of x doesn't equal to x, then your answer is just not inverses. Don't worry about the other half because you'll just be wasting time. But if the first f of g of x does equal to x, then do go ahead and try the other way around, which is the g of f of x. So try plugging in the f function into the g and see if that equals x, and just to double check that they are inverses. But for this one, they're not. So I know for a fact, like that's not going to equal to x. So pause for questions. Okay, so 10.3 is you need to know how to graph a cube root function, which, like I just said, we basically just did that on the front of the notes when we did the inverse of a cubic, but let's just do it again. So in order to graph the cube root functions, let's first graph the parent. The parent cube root is y equals cube root of x. So again, this is not right. This table is not right. Fix it for me. That should be -8 right there. And that should be +8. Okay, so fix that little table on there. All right, in order to graph a cube root, let's graph the parent by first starting with x equals -8, since that's a perfect cubic. So if you do the cube root of -8, that comes out to be -2, because -2 times -2 times -2 would give you -8. Okay, keep going. If x equals -1, the cube root of -1 is -1. So again, that's why cube roots are easier than square roots. There's no imaginary numbers. It always works for positives and negatives. Next, if x is 0, the cube root of 0 is 0. Next, if x is 1, the cube root of 1 is 1. Next, if x is 8, the cube root of 8 is 2. So let's graph that here. I like to graph like 0, 0. That's called the inflection point again. So 0, 0, 1, 1, 8, 2, and the graph is concaved down like this. Zoom in. The other half is still going to be sort of symmetrical or rotational symmetry. So it's going to be -1, -1, -8, -2. And it looks like that, concave up. This middle point is still called the point of inflection. Inflection point. And it's also called the point of rotational symmetry. / rotational symmetry. Okay, so let's answer some questions about the parent. The domain and the range should be all real numbers. So, yeah. Domain, range, all real numbers. The intercept is 0, 0. And now let me show you how to do a couple of these graphs. Now I need you to practice graphing some of the cube roots down here, numbers 1, 2, and 3. Let me just do number 1 all the way, and then you can try 2 and 3. But the way you would graph your cubic or your cube roots is I graph them by looking at the transformations. So if my equation has an A value or a D value, those are vertical transformations, and they're going to affect the Y values. So Y values. If the equation has a B and a C, those are horizontal transformations, and they're going to affect your X values. So let me show you how I would do number 1. And remember, you could always just do your own table of random values just to make it work. So here's how I would graph number 1. First, I always look to see if there are any shifts. So number 1, the inflection point is still 0, 0 because it wasn't shifted left, right, up, or down since there are no C or D values. So that means my inflection point is still 0, 0. However, okay, here's how I do it now. So I know that the parent graph from 0, 0, like I know the parent graph would have been 1, 1 and 8, 2 because the cube root of 1 is 1 and the cube root of 8 is 2. However, what I'm going to do for this problem, I'm going to change the Y values. These Y values, they're going to be multiplied by a -½ because I have an A equals -½ So what I'm going to do is instead of graphing 1, 1, I'm going to graph 1, -½ So right here, to the right one, down half. Same thing with the other point, the 8, 2. Instead of graphing 8, 2, I'm going to graph 8, -1 because I'm taking this 2 and multiplying by a -1/2. So I am changing the y values. So therefore I'm graphing 8, -1. And it looks like this. The other half of my graph is going to just have some sort of symmetry. So it's going to go to the left one, up half, and to the left 8, up 1. So that's how I graph these. Last week I showed you how to make a little table. You could do the table, or you can just make like randomly start guessing x values and finding y values. But that's how I graph all these cube roots and cubics. Let me finish number 1 and then I'll give you time to try 2 and 3 by yourself. So for number 1, Seth, question?
Yeah.
Pause for questions.
So say that.
Right. So the domain and range are always all real numbers, just like it was last week for the cubics. The point of inflection on number 1 is still 0, 0 because there wasn't any shifts. The x-intercept is still 0, 0. The y-intercept is still 0, 0. The minimum, remember I showed you last week, what we need to do is we need to look at the interval from -1 to 3. So in other words, look at the domain and only look at x equals -1. So like right here, up to x equals 3. 1, 2, 3, right here. So by looking at the graph, this graph has a, on the interval from -1 to 3, it has a minimum at x equals 3. And it would have a maximum at x equals -1. But we're looking for the minimum. So the minimum was going to happen at x equals 3. And now we need to approximate it. Like the actual minimum should be the y value. So that's just going to be -1/2 cube root of 3. Because if you plug in x equals 3, like I was just saying earlier, there isn't a cube root of 3. So I'm just going to leave it as -1/2 cube root of 3. And that's what the minimum is, -1/2 cube root of 3. Let me do transformations and then I'll answer questions while you try examples 2 and 3 by yourselves. So transformations, there was only an a value. So that means that the transformations are vertical compression by half. I'm going to abbreviate because I don't like to write them a lot. And these transformations are multiple choice on your test and quiz, so you would just select the right one. Vertical compression by half. And then because there's a negative, that's called reflection over x-axis. So I'm going to pause for questions and then I'm going to let you try examples 2 and 3. Alright, I need you to try examples 2 and 3 and see if you can figure them out. But on number 2, here's what I would do. If I were to graph example 2, first I would graph the inflection point. So because it says x plus 6, that means that it is shifted to the left 6 and then up 4. Oh, I guess let me just do it. Left 6. 1, 2, 3, 4, 5, 6. And then up 1, 2, 3, 4. Okay, so here's the inflection point on number 2. It is -6, 4. And remember, so what I do is I pretend that that's like my 0, 0. Like I pretend that that's the origin. And if there were no stretches or shrinks, like if you were just doing the parent, it would be 1, 1, 8, 2. Because that's what the parent looks like. Like you would go to the right one, up 1, to the right 8, up 2. Like that would be the parent. However, for number 2 here, there is an a value. And the a value here is -2. So that means that I'm going to take the y values again, so these right here, and I'm going to multiply them by -2. So instead of graphing 1, 1, I'm going to graph 1, -2. And instead of graphing 8, 2, I'm going to graph 8, 2 times -2 is -4. And when I mean 1, -1, sorry, 1, -2, I mean that from the inflection point. So let me erase the parent. So from the inflection point, I'm going to graph 1, comma, negative 2. So the right one, down 2. And then again, for the 8, comma, negative 4, that means from the inflection point, I'm going to graph to the right 8. 1, 2, 3, 4, 5, 6, 7, 8. Down 4. 1, 2, 3, 4. So the graph looks like this. The other half is sort of symmetrical, so instead of doing to the right one down 2, I'm going to do to the left one up 2. It's going to go that way. If that method of graphing, I guess the Mrs. Garcia, if that doesn't make any sense, then that's okay. You can just make like your own table of values here. And when you start picking your values, here's the best way to do it. And I don't know if I mentioned it last class, but you start with the inflection point. So we already know if x is negative 6, y is going to be 4 because that's the inflection point. Then from there, pick a point after negative 6. So like we're on, with the negative is backwards, but pick like negative 7. Well, actually it should be negative 7 over here and negative 5 right here. There we go. So go ahead and plug in x equals negative 5, evaluate that to get a y value. Go ahead and put x equals negative 7, evaluate that and get a y value, and it's going to give you these y values, and then you can just make the graph curve. And there's multiple choice on your test and quiz, so just pick the one that looks right with the right inflection point. So that's how you could also graph the cubics and the cube roots. Let's finish the domain and range. All real numbers, always. Inflection point is negative 6, comma 4. The x-intercept, I think you can see it from the, well, I can see it from the graph because I see that it's 2, comma 0. Remember that if you can't see it from the graph, the way you would find the x-intercept is you go to your function, you plug in 0 for y, like here you would put 0 for y, and then you would solve for x. So if you can't see the x-intercept from the graph, you would go to the function, plug in 0 equals negative 2, cube root of x plus 6 plus 4, and then try to solve for x. But I can already see it's 2 zeros, so I'm just going to skip that. The y-intercept, okay, so the y-intercept, I can't see what it is. It's some kind of fraction there. So for that, to find the y-intercept, go to the function again. So go to the equation, and this time plug in 0 for x. So my y-intercept is going to be negative 2 cube root of 0 plus 6. So cube root of 6 plus 4. And you can't evaluate that. That's just going to stay like that. So these are going to be multiple choice again on test and quizzes. So you would just select the one that has 0, comma, negative 2 cube root of 6 plus 4. Let's try the max and min again and the transformations. So you're looking for the minimum again from negative 2 to 4. So let me find negative 2. That's negative 2. To 4. 1, 2, 3, 4. Again, the minimum here is still going to be at x equals 4. And in order to find the minimum value, you're looking for the y value. So plug in x equals 4 to find the minimum y value. So if x equals 4, this would just be negative 2 cube root of 4 plus 6 is 10 plus 4. Looks like that. And then finally, I'll list the transformations, and then I'll answer any questions you might have before you leave. Transformations. Reflection over the x-axis. X-axis. Vertical stretch of 2. And then I guess you can do the vertical shift. Up 4 in the horizontal one, left 6. Let me pause for questions, and then y'all can try the number 3. Okay. So for the last one, example 3, I first need to graph the inflection point. So remember, to graph those inflection points, you're going to have to factor this out. So this is going to become y equals 2 cube root of, we need to factor a 1/4 here, 1/4 x minus 2? Minus 3? Yeah, I think it needs to be a minus 2 here because 2 times 1/4 gives you this 1/2. So now that I have it there, I'm going to first graph the inflection point, which is going to be at positive 2, comma, negative 3. Positive 2, negative 3. So you could start just making some, guessing some x values based on that. Or if you want to do it the way I do it, remember, I take the parent point. So remember how the parent points were like 1, 1 and 8, 2? But this time, because there's a vertical stretch of 2 here, what I'm going to do is, technically, I guess, I'm just going to take the y values here and multiply them by 2. So I'm going to do 1 times 2 is 2 and 2 times 2 is 4. However, when you get to the x values, there's a 1/4 right there. That 1/4 is actually a horizontal stretch of 4. So it's going to be like a 4x right there. So that means that you would take your x values and multiply them by 4. So 1 times 4 is 4, and 8 times 4 is 32, which is not going to fit on here. But, so here's how finally I'll graph it. From the inflection point, I'm going to do 4, 2. So that means from the inflection point to the right, 4, 1, 2, 3, 4, up 2. And then technically, I'm supposed to do to the right 32, 4, but that's not going to fit. So let's just make it go like that. The other side should be like symmetrical. Since they're going to the right 4, go to the left 4. 1, 2, 3, 4, down 2. So that's what it should look like. Practice this. Let me stop the video.